Hello, in this video I will show you how to use connected clusters, and as you can see, connected cluster is pre-fragmented object. Here are my fragments here. All of them are children of one root, and this is the object to which you should apply Rayfire Rigid to and set object type to connected cluster. And when you start simulating connected cluster, as you can see, this root gets one rigid body component. All fragments get only colliders. There are no rigid body components on every fragment. So all this group of fragments simulates as one object. Also, if you will take a look here, let me change to wireframe. Here you can see these blue lines. They represent connections among these fragments. So when this object will be demolished, it will check for connectivity. And if there will be no connectivity among these fragments, they will start simulate separately as lesser connected clusters or separate fragments. Here you can see it simulates as one object, but if I will move it upward, so there will be bigger collision strength. You see, this time it was demolished here, but the rest still simulates as one object. One of the benefits of using connected cluster is that even if you are not going to demolish it, you can use them as concave objects, as dynamic concave objects, because Unity physics can use concave objects only for static objects. If you will simulate your objects dynamically, if you will set kinematic simulation type or dynamic simulation type, then all their concave areas will be lost, because in best case, Unity will create convex hull for all such objects. So here's is my not fragmented tube. And when I simulate it as dynamic object, you can see that this cube falls to this not visible convex surface. And also the same, you can see at the bottom, this tube fall to this cube, but nothing can go through this tube because there is one convex hull right now. And this is the only way you can use dynamic objects. You can see, obviously this is not okay. So this is how we can create convex colliders. Here I have this Rayfire shader. I fragment my tube to 100 objects. Now I can hide this original tube. Here are my fragments. Now I apply Rayfire Rigid component. Let it start. Object type to connect cluster. As you can see, demolition type set to none because I'm not even going to demolish this connected cluster right now. I just want to simulate it as dynamic object. Now you can see this time it works as one concave object with this hole. And you can simulate it dynamically and it will work as one concave object. So this is one of the benefits of using connected clusters. First property in cluster demolition is connectivity, and it defines algorithm which will be used to establish connections between these children of this object with our rigid component. So the first one is by bounding box, and this is the fastest algorithm which can be used in runtime. It works almost instantly, but it is the least accurate. As you can see here, my cubes here, you can see there's gaps between some of the fragments. This one rotated. So this algorithm checks for bounding boxes and create connection between fragments if their bounding boxes overlap with each other. Here I created this representation of these bounding boxes. As you can see, all of them are world aligned. You cannot rotate them. They always will be aligned with world. And as you can see with this cube here, it is the same cube as these cubes, but since it's rotated, its bounding box is bigger. So you should keep in mind this, because with connected clusters rotated differently, you will get different connections. But anyway, this is the fastest algorithm because it only have to check for bounding box connections. And here you can see I click editor setup. If I go to wireframe, you can see there's just blue lines, which means that all these fragments connected right now. The next connectivity type is by triangles. It works well for Voronoi fragmentation in case you have Voronoi fragments. So in this case, you can see I have this subject here. There are two triangles here, and the same triangles you can see on this subject here. As you can see, they perfectly match each other. So this algorithm checks for matching triangles, and if it finds at least one triangle on every object, like this one, and then the same triangle on this object, it considers these two objects as connected. You can see I click editor step and it creates this connection. But if I will, let's say, rotate this object, even though they will perfectly match each other, you can see right now this edge on this object goes from this corner to this corner, and for this object it goes from this corner to this corner. So right now these triangles do not match each other, and this time this algorithm will not work. But if you use Voronoi fragments created by shader component, in most of the cases, their triangles match each other, so you can use this connectivity type. But then there's this another by polygons connectivity type. This is the most accurate connectivity type because instead of checking for just one triangle, it creates these polygons, which consist of multiple triangles. So it finds all planar triangles and consider them as one polygon and do the same for the other object. So in this case, you can see I also have these triangles, but this time they do not match each other. So here you can see this edge goes from this corner to this corner. In this case, it goes from here to here. But if you will use editor step, you can see it still creates this connection. And this is how by polygons connectivity type works. Also, there is this combination of this bounding box and by triangles and by bounding box and polygons. So in this case, you can see I have these two cubes. Polygons do not match polygons to their neighbor fragments. So some of them match each other, but then there are these two cubes that doesn't match. So if you still want to create connections in this kind of structures with a lot of matching fragments, but still there will be some fragments that cannot be matched by the triangles or by the polygons, and you still want the structure to be correct, you can use this hybrid connectivity type by bounding box and polygons. So first it will check for connection by polygons, and then it will check for the rest of the object for connection by bounding box. You can see it still creates these connections between all these fragments. So when you initialize your connected cluster, this is the moment when it gets all these connections and when it applies colliders to your mesh fragments and performs all heavy calculations. But if you don't want to do this every time when you initialize your connected cluster, if you use prefab and you are going to instantiate this prefab a lot of times, then it's better to use this editor step button. And as you can see, it got all these colliders right now. Also, you can see all connections that was created. If I will start play mode now with this one and initialize it, you will not waste your resources at this moment because everything already cached, already stored inside. And obviously it will work much faster if you won't perform these calculations every time you instantiate object. In this case, you just did this once in editor step. Next time it will just use this information and will not waste the resources to calculate all this information. But keep in mind, if you will decide to change some of your properties like connectivity type or collider types, then you need to click reset step, change properties to some other, then click editor step again. Otherwise, these changes will not be reflected in your setup. One disadvantage of using this editor step only is that you will increase the size of your prefab. So I will create prefab with this one, and I will create prefab with this one. Now, if we will check their size, you can see that size of the prefab with cached information is much bigger than this one. So it's up to you to decide. If you do not care much about space of your build, then it's much better to editor setup to have all information cached. And then every time when you will instantiate your prefab, you will not spend time to calculate this every time. So you can see I created prefab, everything already calculated, all connections there. I just initialize it and it simulates instantly. And in this case, I will need to initialize it every time and make all these calculations over and over again. Next group of properties here are filters, and they allow you to decrease amount of connections, and this will make your connected cluster more fragile. So when you will demolish them, demolition will look more real and more natural. By default, when you demolish your connected cluster, it demolishes near the collision area, but using filters, you can also add the secondary demolitions at other areas. So to show you difference, let me show you how it looks. So in this example on the left, I do not use any filters. And when I use Editor tab, you see it says here 663. And as you can see, everything is connected. And in this example, I will use minimum size filters. Also, I will add this random percentage filter, so it will just randomly remove some of the connections. Also, take a look at this area here. You can see I have here a lot of small fragments, much less than here. With my minimum size filter, when I use Editor tab, you can see that there are completely no connections here. When I will start simulating, this column still will be simulated as one solid object. It will not break because there's no any connections here. But after first demolition, it will check for all the connections, and then it will see that there are no connections here. It will at the same time separate my column to two lesser clusters. Let's take a look how this looks like. So here's default demolition. You can see this rock collided with connected cluster here, and only a couple of fragments here at the collision were demolished and detached from the connected cluster. It almost stayed the same. There's another fragment here. In this case, I'm using twice less connections, and when I demolish this column, now you can see it was demolished near collision area, and since there were any connections at the middle, it also was this upper part crumbled down, and you also get this small connected cluster here. This is also connected cluster, and as you can see, using some filters to decrease amount of connections makes your demolition, I guess, a bit better than if you use just all connections you can use. Also, another reason to use filters is that, let's say, if I will use here, as you can see with by polygons, it creates 663 connections. But if I will change my connectivity to by bounding box, obviously in this case you'll get much more connections. You can see it almost 1000 connections here. So just changing connectivity type, you make your connected cluster much more or less fragile. And in this case, you can just use some random percentage filter to decrease amount of fragments, I mean connections here. Just one more reason to use filters. So next properties here are demolition distance properties, and this is where you can define how much fragments will be detached from your connect cluster when it will be demolished by collision. And there are two ways to define this distance. One is in whorl units. In this case, you just set exact units. Also, there is a ratio to size, which I will show you later. So for this right example, I'm using just 1 unit. For this one, it's 3 units. For this one, it's 6 units. And I'm using this prefragmented cube, so it will be just easier to see how different value works. Now let me demolish my connected clusters. So here you can see this was the cluster with 1 unit. And as you can see, all fragments starting from the collision point in 1 unit radius were detached into separated fragments. All these fragments got rigid component with mesh object type. And in this case, it was 3 units. And as you can see, much more fragments were detached into separated fragments. And in this case, it was 6 units, so that was all what was left from the original connected cluster. Another way to define this distance is by using ratio to size. So in this case, you set this distance in percentage relative to original cluster size. So in this case, 20 means 20% from the original connected cluster size. This way, you can define approximate demolition area when connected cluster will collide with something. So no need to measure exact units. If you want half of your object to be demolished, you can just set here 50%. And then when it will collide, half of the object will be detached from the connected cluster. And all fragments in this 50% radius will be turned to separated fragments. So in this case, I'm using 20%. In this case, it's 50%, and in this case, it's 90%. And it provides pretty similar results. As you can see here, 20% starting from the collision point were detached. In this case, I was using 50%, and as you can see, half of the connected clusters fragments were detached into separated fragments. And in this case, it was 90%, and this is what was left from the original connected cluster. Okay, after you demolished your cluster, at the collision point, you detach a bunch of fragments, but then using the shards and clusters properties here, you can define what will happen with these fragments. Using the shards area, you can define how many fragments will be left separated and how many of them will be combined back to small clusters to create this smooth transition starting from the small fragments at the collision. Then there will be a bunch of small clusters, and then there will be what was left from the original cluster. To explain you this, let me show you. So in this case, I am using 50% shard area. Here you can see I demolished my connected cluster. This is what was left from original cluster because I have demolition distance 5 units. This was 5 units starting from the collision point, which were detached into separate fragments. But here you can see I have here the small connected cluster, and then there is another one and another small cluster here. So this is a work in this way because I have 50% for shards area. So this is my demolition distance area. This is demolition distance area, my 5 units, and 50% from them, this 50% were kept as shards, as separate fragments with mesh object type. And then the rest 50% was turned into small clusters to create a smooth transition. So when you break object, you get a bunch of separated fragments, then a few small clusters, and then the big cluster from original connected cluster. This is how the shards area work. In this case, I have set it only to 20%, so I will get a little bit of separated fragments, and then there will be 80% of the fragments turned into clusters, and then what was left from the original clusters. So this is my original cluster. Then I have 80% of the fragments turned into clusters, and then this 20% of the fragments which were turned into separated mesh objects. And in this case, I set it to 90%. And in this case, I will just get a lot of separated fragments. You can see there are no any connected clusters. Okay, there is one. So this one is small cluster, and this one as well. But the rest of the fragments are separated mesh object fragments. So this worked in this way because I have set here 90% of shards area, I want to keep us just regular separated mesh fragments. Do not do anything with these fragments. Just keep them as mesh fragments, and the rest 10% turn to small clusters. So this is how this shard area works. It's a bit tricky, but you just need to play with it a little bit and you'll get used to this. In previous part, I explained how to control amount of shards after a cluster will be demolished, how to get this simple separated mesh fragments using this shards area property. And now I will explain how to manage amount of clusters, the small clusters, which will be created in this demolition distance area. To manage amount of clusters, you can use this minimum and maximum properties in this clusters properties here. Here you can see I set it to 2. In this case, it's 3 to 6, which means that there'll be random value picked in this range. For this one, I set to 7. Also, as you can see, I'm using the shards area set to 0. It means that after demolition, in this 6-unit demolition distance, all fragments which will be detached, they will be clustered back to small fragments. It means that there will not be any separated mesh fragments after that. Now let's check how this looks like. So here you can see I demolished my original clusters. This is what was left from them. And in this case, I have set my min max to 2. And these are 2 clusters which I got. In this case, I'm using value 3 to 6. And these are the clusters which I got in this case. As you can see, I have 5, actually 6 clusters. But that will be random value in this range from 3 to 6. And in this example, I'm using 7. So that's 1, 2, 3, 4, 5, 6, 7. Also, there's this one mesh fragment which couldn't get into any clusters, but that's okay. So this is how this cluster minimum and maximum properties works. It is possible to demolish mesh shards after cluster demolition into little smaller mesh fragments. To do so, we need to use this demolition property here. As you can see, I set here shards area to 100%. It means that I will get only shards, only separated mesh fragments. There will not be small clusters. And this is default behavior with the disabled demolition property. You can see I simply demolished my cluster. I get a bunch of fragments. If I'll select them, they will have this rigid component, mesh object type, but they demolition type set to none. So right now, just a simple rigid body simulated objects. But in this case, I enabled this demolition property here, and as you can see, when you enable it, it reveals this mesh demolition properties, which you can define mesh demolition properties, which will be used for all these shards. Now you can see I demolished, this is my original cluster, and if I will pick one of these fragments here, you can see their demolition type set to runtime. It means that now they will collide with each other, with ground, with other objects, and it will be possible to demolish them into smaller fragments. And obviously this is a pretty resourceful feature because you have a lot of fragments which can be demolished in runtime. But in case you really want to create something like this is the property you need to enable. And the same demolition property you can use for these small clusters, which will be created in this demolition distance area. As you can see, I set here shards area to 0, so I want to clusterize all detached shards back to clusters. And I set here I want 2 clusters. In this left example, demolition is disabled. On the right example, it's enabled. Now let's look how it works. So this is what was left from my original cluster because I set here demolition distance to 80%. And then I have these two clusters which were created thanks to this min-max values. And you can see their demolition type set to none. So it is not possible to demolish them anymore. They always will stay the same as not demolishable rigid body objects. And in this case, demolition is enabled. So this is a cluster which were left from original cluster. Then I have these two clusters, and for them demolition type set to runtime. As you can see, their demolition distance ratio also set to 80, so they inherit all the properties from the original cluster. And this is the reason why you should use ratio to size in case you want to demolish these small clusters as well. Because if you will use exact world units, then they will be the same for all the small clusters as well. And since they're smaller than the original cluster, for them exact world units value might be even bigger than their size. But in this case, they use this ratio to size value, which will work for them as well. And you can see I can simulate them, and they also will be demolished during simulation. And their clusters as well also will be demolishable. So this is how this demolition property for cluster works. And next group of properties here is collapse, and collapse allows you to create crumbling demolition by destroying connection between fragments. If fragment has no connection with other fragments, then it will be turned into single separated mesh object. And if there will be group of fragments, they will be converted into smaller connected clusters. You can destroy these connections by shared area size, by fragment size, or randomly. Now let me show you here. You can see my column. And as you remember, there are a lot of small fragments here at the middle. And obviously, small fragments will have small shared area size. I can use these three sliders on top of the rigid component to test collapse. And when I will start increase by area, all shared area size less than this value will be destroyed. And all fragments will check for connections with each other. So here you can see I started crumbling at the middle. And if I will pick this cluster, you can see this is another smaller cluster. It also has the same sliders, so I can play with them as well and continue my collapse of the smaller connected clusters as well. With this column, I will use this by size slider, but again, I think it works in pretty the same way because most of the small fragments at this area. So in this way, you can add more kind of crumbling demolitions to your simulation. So you don't need to hit it by something to demolish it. You just can play with these three values and to get some kind of crumbling demolition. And in this third example, I will just use this random spinner. It works from 0 to 100, and 100 means that all connections will be destroyed. You can see I am increasing it, some connections start destroying it, and then you can see these fragments starting to crumble. So you can use these three ways to create demolitions. In next part, I will show you how to use them in your game build. So using these sliders, you can play with your collapse setup in editor just to test it. But if you want to create collapse in your build, first of all, you can use this public static methods in ref collapse class. As you can see, first you need to input this rigid component which you want to demolish, which is connected cluster. Then if you will input integer, it will work as percentage. So if you will put 20, it will mean that 20% of smallest connections based on shared area will be destroyed. If you put float value, then it will work as units and it will destroy all connections with shared area size less than this input value. In the same way, it works for size collapse, and random collapse already works in percentage from 0 to 100. And if you do not want to use these public static methods, then you can use these built-in properties here. In this case, you just need to define the way you want to create collapse, starting value in percentage, end value in percentage. Then you define steps, means how many times this method will be initiated for this connected cluster, and duration, which will your collapse, and duration during which will happen this collapse, and then variation property for all these values, and seed for all the random values. So just let me show you how it works. Here you can see I have by area size from 0 to 60, and this method will be initiated 10 times during 20 seconds, which means every 2 seconds. And this is how it works. All you need to do is just click the Start Collapse button or use Start Collapse public methods in Rayfire Rigid component. In this case, I will use by size. And in this case, I will use just this random collapse. So as you can see, all you need to do is just put all these properties in advance and then just click here Start Collapse or use the Start Collapse public method, and you'll get your slowly crumbling structure. And at the end, I want to show you a couple of other two ways to demolish your connected cluster. First one using this Rayfire bomb component, and there will be another video tutorial about bomb component, about gun component, and about these damage properties which I'm going to use. For now, I just want to show you what you can do if you will need, so you will be able to check these tutorials for more information. So first way is to use Rayfire bomb component, and in this case I'm not exploding anything. As you can see, my strength for bomb is set to 0 and my fate set to none, so there will be no fate in this strength and damage distribution. I enabled my damage property here, so I will apply damage to this connected cluster, and you can use this 100 value. The next thing you need to do is go to this connected cluster, enable damage property here. Also, you should enable this to shards toggle, so when you apply damage, every shard will get its own damage, not whole connected cluster. And here I set the max damage to 10. So it means that when I will apply this 100 damage, all of them will get the maximum damage they can take, and they will be detached from the connected cluster. So all you need to do now is just explode it using explode method, and you will demolish your connected cluster exactly where you want it to be demolished. So you can put it whenever you want, set some radius of where you want to demolish your connected cluster, and then explode this bomb without actually creating any explosion. But if you want, you of course can, let's say, use some value here. So not only demolish connected cluster at this area, but also explode these fragments. Well, that's probably too much. Well, you got the idea how this Rayfire bomb demolition works. And next way is to use gun component. Here you can see I put this gun. It has its radius, impact radius. You can enable this show toggle to see the radius of this impact. It works only if you have colliders. So you can see my impact radius. Maybe I will move it here. And again, you can use this damage feature just like bomb, but Rayfire gun has this demolish cluster toggle. So you can enable it and you don't need to have this damage enabled in connected cluster. In this case, the first shot of this gun will be enough to demolish and detach all these fragments inside this impact radius. So just enable demolish cluster here, and the first shot will demolish them. But if you want to make several shots in case you don't want to create demolition after first shot, you can disable this toggle demolish cluster and use damage just like with bombs. Don't forget to pick here shards in impact radius, otherwise you will apply damage only to one shard. And in this case, you will apply damage to all shards inside this impact radius. And in the same way, you can set here damage, let's say 20. And for shards, I will set here enable damage, enable to shards. And here I set 50, so it will take 3 shots to apply enough damage for every shard. And after that, they will be detached from the connected cluster into separate fragments. So here you can see I can make one shot. And here you can see this red digit show you the damage that every shot right now have. Right now it's 20. I can make another shot here. Now it's 40. Maybe I will move here. And this time it was enough to apply enough damage to some of the shards and to demolish this connected cluster. So this is how we can demolish connected clusters using bomb and gun component.